So I will start to represent the code written in my IDE. So I use IntelliJ. So this is the classes that we have for this project. We have commission worker class, employee class, hourly worker class, monthly worker class, and also salary calculator class. Basically, salary calculator class is the main class, which is salary calculator. We can see here. So this is the code for the salary calculator. Alright, so this is the pay code in switch pay code. For case 1 is for pay code number 1, case 2 is for the pay code number 2, which is for the monthly salary, and pay code number 3 is for the commissions worker. So next, this is the total salaries that will be represented at the end of the program. Alright, so we move on to the next, which is the monthly worker class. So this is the code for monthly worker. Next is for the hourly worker class. We have here. Next we have for the commission worker class. This is the commission worker class. And also, last but not least, for the employee class, we use the abstraction. So right now, we move on to the next, which is I'm going to run the program. So basically, we need to go to the salary calculator Java, and then we run it. We enter pay code number 1, enter the number of workers 2. The salary is RM400. The salary is 4,000 ringgit. And then for the pay code, we enter pay code 2, enter the number of workers, we put 2, the number of hours worked, we put 50, and the salary, we got 3,300 ringgit. And then we enter the pay code 4, which is invalid code, and then enter pay code 2 again. The monthly salary has been calculated as we already calculated here, and then enter pay code 3, enter the number of workers 1, the weekly sales 10,000, and the salary is 1,050 ringgit. And then if we want to terminate the program, so we just put -1, and then it will display the total salaries that needed to be paid. So RM 8,350 ringgit. So this is how the program is run, and this is the result of the program. Object-oriented programming, OOP, is a way of writing computer programs that revolves around the concepts of objects. So objects, what are they? Objects are like the containers that store information, data, and the things that you can do with the information. For example, think of a car as an object. It has data like color and speed and actions like start and stop. So classes. Classes, what are they? Classes are like blueprints or templates for creating objects. They define what an object will be like. For example, the blueprint of a car class defines what all cars should have. For example, a car should have color, speed, start, stop, etc. So without further ado, we are going to go into the details by explaining the 4 basic principles of OOP, which are encapsulation, polymorphism, inheritance, and abstractions, by looking at the coding. So I'm going to start with the first one, which is the encapsulation, where encapsulation is like putting your data and function in a box. It keeps things organized and protects them from outside interference. For example, imagine putting the details of a car like color and speed in a box so that they are safe and not messed with randomly. So the example in this coding, which is in the monthly worker class, where the monthly worker class encapsulates the information about how the monthly pay is calculated. The calculate pay method is an encapsulated part of the class that is responsible for determining the monthly salary. Okay, that one is for the encapsulation. Now we're going to move on to the inheritance, which is the inheritance is a mechanism in object-oriented programming that allows a new class to inherit properties and behaviors of an existing class. It promotes code reuse and establish a relationship between classes. So in this coding, we can look between two classes, which are monthly worker and employee worker. The monthly worker extends the employee class, which inheriting the abstract method of calculate pay. This relationship implies that a monthly worker is a type of employee and it must provide its own implementation for calculating pay. Okay, so next we are going to explain about the abstraction. Okay, abstractions involve hiding the complex implementation details and showing only the essential features of an object. In Java, abstraction is often achieved through abstract classes and abstract methods. So we can look at the example of the employee class we have here. The employee class is abstract and it declares an abstract method called calculate pay. These abstract methods serve as an abstraction because it provides a common interface for all types of employees, but the specific implementation details are deferred to the subclasses. And last but not least, we have the polymorphism. Polymorphism allows objects to be treated as instances of their parent class and enables flexibility in method invocation. Polymorphism use those methods to perform different tasks, and this allows us to perform a single action in different ways. So we have two types of polymorphisms in Java, which are method overloading and also method overriding. So in this example, monthly worker overrides the calculate pay method from the employee class. Polymorphisms allows a reference to an employee object to call the calculate pay method, and at a runtime, the overridden method is monthly worker is invoked. So, in summary, by applying all these OOP principles in the coding provides a modular, organized, and maintainable structure. It enhances the code reusability, reduces duplication, and allows for the extension of the system with new employee types. Additionally, it simplifies the code by extracting away unnecessary details and enables flexible interactions between different objects. Thank you.